Welcome back, Patriots. This is Mr. Love, also known as the Math Patriot, bringing you another fun and exciting lesson in the world of high school geometry. Today we're covering our last section in our surface area and volume unit. We're going to be going over spheres, and I saved the best for last because spheres are one of the easiest ones. Now, we're going to have to learn how to do a new function on the calculator for one of the pieces of this, but nothing is going to be too bad. So, just like before with the last two, because of the amount of work I'm having to cut out on things, we're going to be talking about surface area, but we're not going to actually be calculating them. I want to show it to you, but not going to actually make you do any of it. So, let's go ahead and jump through. So, sphere is a set of all the points in space that are the same distance from a given point. Exact same idea as a circle, except a circle is two-dimensional, whereas a sphere is three-dimensional. No faces, no edges, no vertices, because it is curves all the way around. Now, a sphere has a radius, just like a circle does. It also has a diameter, just like a circle does. The only difference is, like I said, it's three-dimensional. Now, we've also got this idea of a great circle, which means if I was to slice a plane straight through the center or through a diameter, then the intersection of the sphere and the plane, which is right here that I'm highlighting in orange, that would be the great circle. Now, the endpoint of a diameter on that great circle is a pole. So if you think about our globe, and I'm not the best at drawing these. Okay, you've got the North Pole up here and the South Pole right here. What's actually going on here is that we've taken a plane and sliced it through the globe vertically through the North and South Pole. Here's the center. We've actually gone through and sliced it right here, and then the endpoints of the diameter, those are the two poles. Now, a hemisphere is one of the two congruent parts of a sphere when a great circle separates the sphere. A hemisphere is half of a sphere, and then it does have a base. That base down there is a great circle. Great circles are very important for things like navigation and aviation because the shortest distance between 2 points on a globe is not necessarily a straight line when you have to follow the surface of the globe because you have to go around like this. The shortest distance is actually along a great circle. So if you ever get into aviation, you might get into great circles quite a bit. All right, surface area of a sphere. The first time I saw this formula, I thought someone was lying to me. It is bizarre that if I take the area of the great circle, which is this circle right here, that area of the great circle is pi r squared. However, if I want to find the surface area of the entire sphere, it is 4 great circles. 4 times pi r squared. I didn't believe this until I actually went through and took an orange and, took the orange and then traced out 4 circles that were the same diameter as that orange, and then peeled it and started putting all those pieces inside, and sure enough, that thing filled up exactly 4 of those, give or take a little bit, because when you peel an orange, it's like exactly perfectly separating the peel, but sure enough, it worked out to be 4 of those circles. If you want to give it a try, hey, you're sitting at home with not much to do anyway, so might as well peel an orange and see how many circles it makes. Sure enough, surface area is 4 pi r squared, or 4 great circles. Oh, incidentally, if I took a hemisphere and wanted to find the surface area of that, the surface area of the hemisphere would be 3 pi r squared. The reason for that is it's half of the sphere, so the spherical, the domed part would be 2 pi r squared, and then the great circle on bottom, this down here, would be another pi r squared. So the surface area of a hemisphere is 3 pi r squared. Okay, find the surface area of the sphere to the nearest tenth. I'm going to do a couple examples of this. I'm not going to make you guys do it on the assignment. Okay, so here I've got my diameter drawn. So if the diameter equals 7, then the radius equals 3.5. Then the surface area is just going to be 4 times pi times r squared. So, just like we did when we were doing areas of circles before, I'm going to do everything except for pi. 3.5 squared times 4 gives me 49 pi inches squared. If it asks me for an exact answer, that's what I'm going for. If it asks me to round, like it does here, nearest tenth, I'm just going to do 49 pi and then round it to surface area equals 153.9 inches squared. Oh, incidentally, before we've had surface area and lateral area. Spheres do not have a lateral area because they do not have any lateral faces or any faces at all. Okay, find the surface area to the nearest tenth. Here it is 3 pi r squared, as I explained before. So surface area equals 3 times pi times 3.7. 3 pi, 3.7 squared. 129.0 millimeters squared. Okay, or that third one is because we've got 2 for the domed portion and then 1 for the great circle. Okay, find the surface area of a sphere if the circumference of the great circle is 10 pi feet. Okay, now if the circumference is 10 pi feet, we're going to have to go in and find the radius before we can find the surface area. So if circumference is 2 times pi times radius and circumference is 10 pi, we're going to substitute that in. 10 pi equals 2 pi r. Well, I'm going to first start off by dividing by everything on the right here that I don't need. I don't need 2 pi. So I'm going to divide by 2 pi on both sides. Pi's cancel, 10's cancel, or 2's cancel. Pi's cancel, leaving me with r equals 5. Now from there, I'm going to go through and calculate the surface area. 4 pi r squared. So 4 times pi times 5 squared. Now, let's see, 5 squared is 25 times 4, that is 100 pi, which that's one I can even do without the calculator to the nearest tenth. That is 3.1415926 is pi, so that's 314.15, which rounds up to 314.2 feet squared. So important thing there was use circumference to find radius and then radius to find surface area. All right, volume of a sphere. Just like surface area, it's based entirely on the radius, and the volume here is 4/3 pi r cubed. Now, when you get to one of your calculus classes, I believe it's second semester of calculus or calculus 2, depending on how your particular school labels it, you're going to actually go through and learn how to derive this formula for yourself. It's a thing called a washer method, I believe, of integration. Also, you can do the exact same thing with cones. So this volume of spheres and volumes of cones is actually going to come up quite a bit. Well, I'll say quite a bit. It's going to come up again when you get to your calculus classes. But anyway, 4/3 pi r cubed to the third power. Now, the way that we do that in the calculator is one of two ways. So I'm actually going to bring my mouse over so you can see me do it. There are one of those is to use the caret 3. The other one is to do math 3. Either one will get you a cubed. So bring me my mouse over so that you can see it. So let's say that I want to do 2 times 2 times 2 in the calculator. We know that answer is going to be 8. That is 2 cubed. All right, so the easy way of doing that is to do 2 caret 3, and caret is over here by the clear. You'll notice that in this version of the calculator, it jumps up to the exponent position. You have to then press right to get out of it, and that will give you 8. Another way of doing that is to press 2 as the base, and then go to the math button, which is the third from the top on the left, just below alpha, and then you'll notice up here that the third option is cubed. Now, I actually prefer that method when I'm doing cubes because it's going to prevent me from having to press the right arrow to get out of it if I ever need to. Okay. Now, another one that we're going to need in a little bit is the inverse of that, which is the cubed root. So if I had the cubed root of x, that's the inverse of cubing. That one you're going to access from the math menu. That one is math. And then you'll notice here option 4 gives me the cubed root. And then still same thing as square root, it gives me the radical bar that I can then put things inside of. So if I put the cubed root of 8, it's going to give me 2. Now, if you're using a home calculator or a Windows calculator or something, all bets are off on that. As far as how to actually get there, it is very, very calculator dependent. One symbol you might look for is something like this, option 5, that is the X root. The way that that works, if you need it to, you can make that be a square root or anything. You put the index first, so I would put 3 math 4. Oh, sorry. 3 math option 4. Nope, I can't do this today. 3 math, option 5. And it converted it to cubed root for me. So I want to do different order roots. I could do that. On home calculators, things might look a little bit different. And actually, one way of making it work completely, and you'll learn how this works in Algebra 2, is you could, if you needed to, do something like this. Caret, parentheses, 1/3. You'll learn why that is when you get to Algebra 2, but for now, using home calculators and the social distancing thing, it'll work out. So let me just show you how that works. Parentheses 8, parentheses, caret, parentheses 1 divided by 3, close parentheses. That's going to give me 2 as well. So you've got different options. My point is you're going to need that in a little bit, and hopefully you'll have a calculator in front of you that can. By the way, there's several apps that I went over in class that can get you the actual TI calculator on both your Android and iPhone. I highly recommend those here because of this particular scenario. Anyway, back to the lesson at hand. Volume is 4/3 pi r cubed. Okay, find the volume of the sphere, round to the nearest tenth. Volume is 4/3 pi r cubed. So volume is 4/3 times pi. Now we're just going to plug it in. Radius is 8 cubed. And we can type this in exactly like it is. 4 divided by 3 times pi times 8 math 3. Nope, I didn't hit the math button. Math 3 gives me cubed. Volume is 1,044.7 centimeters cubed. Hardest part of this entire thing is figuring out how to type in cubed into your calculator. Okay, find the volume of a sphere. The circumference of the great circle is 30 pi feet. Okay, so circumference of the great circle, which is right here, is 30 pi feet. I want to find the volume. I'm going to do something very similar to what I did before. Circumference is 2 pi r. I'm going to use this circumference to find the radius, and then the radius to find the volume. So C equals 2 times pi times r. Sorry, that C should have been the actual circumference, which is 30 pi. I'm going to do the same thing I did before and divide by 2 pi. That pi cancels out. And I'm left with r equals 15. Now, I'm going to jump into my volume. 4/3 pi r cubed. 4/3 pi times 15 cubed. 4/3 pi times 15, cubed. 14,137.2 centimeters cubed. So, same as before, use circumference to find radius, then radius to find volume. Okay, find the volume of the hemisphere with a diameter of 6 feet. Now, when we're dealing with a hemisphere, all we're going to do is to take the entire volume and divide by 2. So there are 2 ways of doing this. I'm going to show you the kind of, just logic way, and then I'll show you the actual mathematical way at the end. They're equivalent. One just takes one more step. So what I'm going to do is I'm going to find the volume of the entire sphere and then divide it in half. So volume of the sphere is 4/3 pi r cubed. So volume of the sphere is 4/3 times pi times, well, radius has got to be 3 feet because the diameter was 6 feet. So 3 cubed. 4 divided by 3 times pi math 3. Nope, forgot my radius. There we go. 4/3 times pi times 3 cubed gives me volume of the sphere is 113.09, which is 113.1 feet cubed. But now I want the volume of the hemisphere. So the volume of the hemisphere is just going to be volume of the sphere divided by 2. So I'm just going to hit divide by 2 on this, and that's going to give me 56.54, so 56.6 feet cubed. Now, the direct way, volume of the hemisphere, 4/3 pi r cubed, all divided by 2. One of the things you can do there is just cut it in half by making this 2/3 pi r cubed. So volume of the hemisphere is 2/3 times pi times 3 cubed, which means that instead of typing it again, I'm just going to go up and snag this guy and arrow over and change that to a 2/3 pi times 3 cubed, and we get the same thing. Volume of the hemisphere is 56.6 feet cubed. Okay, now I forgot to add in this last example, the one where I take the volume and go to the surface area, just so that you can see how it's done. We're going to go ahead and take a sphere, and we're going to say that this sphere's volume, and let's just make it, I have no idea, let's just make it 300 centimeters cubed, and I want to know what is the surface area. Okay, so volume is 4/3 pi r cubed, so that's 300 equals 4/3 pi r cubed. Now this one is going to work in a similar fashion to what we did when we had the circumference of the great circle. We're going to use the volume to find radius, and then radius to find surface area. So whenever I go through and solve for r on this, what I'm going to do is piece by piece take out everything that's not the r. So first thing I want to do is get rid of that fraction. The way to get rid of a fraction is by multiplying by its reciprocal. So that's times 3/4 on both sides. So that's going to give me equals, let me, pi r cubed. Now 300 times 3/4 is 225 equals pi r cubed. Now we're going to divide both sides by pi. Divide that by pi. And I'm getting that r cubed equals 71.619. Now, this is why that cubed root function of the calculator was important from before. The way that we get rid of a cubed is by taking the cubed root. The inverse is the cubed root of those. So now, cubed root of r cubed is just r. Now we go to math 4 for cubed root, and I'm pressing second answer, which is second and then the negative at the bottom. By the way, if you're going to do this without, you probably need to carry that decimal out, or without the answer option there, carry that decimal out quite a ways so that you don't get a rounding error here. So R is 4.158,305. If I want to get it as accurate as possible without the answer, I would probably actually type in that entire number. But you'll notice, like I said in the previous lesson, I always use the previous answer because that is a truly unrounded value, and I don't worry about introducing rounding errors. So I've got that. Now I'm going to jump over here and do surface area, which is 4 pi r squared. So surface area is 4 times pi times 4.158,305 squared. So 4 times pi times that last answer squared is 52 point, and we went the nearest tenth like we had before, so 58.2 centimeters squared. Okay, now 58.2 is our true answer. Let me show you what can happen with our compound rounding errors, and I'm going to do all of those in green. Let's say that I took at this step right here, okay, let's say that I took that and rounded that to r equals 4.2. Well, then that would mean that I was putting a 4.2 in over here, and now 4 times pi times 4.2 squared. Oh, wow. You know what I just realized? I did not actually put a squared on that. That is a problem. Okay, let me jump up and so I don't have to type this again. Boom, divided by pi. Give me 71.2, math 4 of that is 4.15, and then I need 4 pi times second answer squared. Oh man, let's fix that. That's 216.7 centimeters squared. I hope y'all caught that whenever I did that. Okay, Anyway, back to our rounding errors that we can talk about. Once again, if we round to 4.2 and then put a 4.2 in there, 4 pi times 4.2 squared gives me 221, a full 5 units off, okay? That would give me 221.7 centimeters squared, which is not a correct answer. Now, if you want to carry out some significant digits when we do this, so let's start over back here, and this time let's do this in our blue. So this guy right here, the square root of, I'm sorry, 225 divided by pi. 225 divided by pi. Okay, that was 71.619724. I'm not going to carry all of them out, but I'll use that just to see how close that gets me to the actual answer at the end. Now we're going to take the cubed root of 71.619724, and that's going to give me close enough. My radius is 4.1528305. Well, I guess it should have been 306. Okay, now I'm going to use that in over here for my radius, and 4 pi times 4.1528306 squared, and that gives me 216.7 centimeters squared. Now, here's my point on this. The reason that you want to carry those decimals out really, really far whenever you're in the middle of calculations is you don't want to introduce a compound rounding error. You want the rounding to happen so many significant figures back that it's not going to impact your final answer. If you run it to the nearest tenth on every single step, then you're going to cause yourselves problems. That rounding is just going to compound and compound and compound and cause issues. What you want to do is either the simplest thing, you'll notice how many button presses I'm doing to make this happen. The easiest thing is just to press second answer, which is second negative, and then you don't have to do that, all those different button presses. That's the easiest way of making it happen. Okay, beyond that, if you're on a calculator that doesn't have that option, then you're going to want to take it significantly far beyond the needed scale or the needed accuracy level, 4 or 5 digits beyond, and then you don't have to worry about that rounding affecting you as much. It still can, depending on how many different times you're rounding in the middle of the problem. But that's it for now. I hope that little rounding section wasn't too much at the end, but it's an important topic and it comes up quite a bit whenever my students do their online Google forms and stuff. So that's it for today. As always, guys, stay patriotic.